Hello, welcome back. This morning we're going to be doing section 3.2 from the Intermediate Algebra of Martin Gay, 4th edition. This section is about the slope of a line. I talked about the slope of a line last time, but this is the section that actually asks you to calculate it. So problem 2 says, if you have a point 1, 6 and a point 7, 11, what is the slope of the line that goes between those points? So first let's just plot that out, okay? Because pictures help a lot. So you get the first point, 1, 6, that's here. The second point, 7, 11, that's up here. So the line we're talking about is a line that goes like this. And they want to know, what is the slope? Well, the slope, like I said before, is defined a couple different ways. One of them is the so-called delta y over delta x, or the rise over the run. In this case, let's use the delta y over delta x, okay, because that's what we're dealing with here. XY coordinates. Delta y is equal to 11 minus 6. Delta x is equal to 7 minus 1. So we're just going to call one point we're going to call one point P1 and the other point P2. So this will be x1, y1, x2, y2. So when we take the difference, we'll always go from the second point to the first point. y1 minus y2, y2 minus y1, x2 minus x1. So delta y over delta x, in this case, is going to be 5 divided by 6. Okay, and that is the slope, 5 divided by 6. Okay? Now, it doesn't matter which point you call 1 and which point you call 2. If I had called this point 2 and this point 1, the delta y would have been a negative 5, because it would have been 6 minus 11. But the delta x would have been negative 6. It would have been 1 minus 7. And you find that the ratio is exactly the same. Okay? This is the so-called positive slope line. It's the one, when you plot it on the xy graph, it's pointed up to the right. That's our concept of positive slope. It's just a convention because we always take the positive direction to the right, negative direction to the left. Okay, that's like being right-handed or left-handed. It doesn't matter, you could do it either way. But in math, it's conventional to take positive to the right and positive axis going up. That becomes ingrained into you. Okay, so let's try the next one, number 4. 2, 9, 6, 4. So I'm just going to go right to delta y over delta x. Okay, and we're going to go, I'll just take the second one that I wrote down. 4 minus 9 over 6 minus 2, negative 5 over 4, negative 5 fourths. This one is going to be pointing more in this direction because it's got a negative slope. Okay, but they just asked us to calculate the slope, so that's it. Okay, negative 5 fourths. Okay, now let's go to number 6. 3, 7, negative 2, 11. Delta y over delta x. This is also known as the slope. For some reason, the letter m has been used for the slope. Don't ask me why. Just the way it is. M has been used for the slope. Okay, 11 minus 7. over negative 2 minus 3. Okay? It's equal to 4 over negative 5, or negative 4/5. Okay, also a negative slope. Next one, negative 3 comma negative 4, negative 1 comma 6, delta y over delta x equals 6 minus negative 4, negative 1 minus negative 3. We get a lot of negatives in there, but that's just 6 plus 4 over negative 1 plus 3. That's just equal to 10 over 2 equals 5. That slope is 5. Okay. Okay, let's go to number 10. 3 comma negative 1, negative 6 comma 5, delta y over delta x. Now, 5 minus a negative 1 is plus 1. Negative 6 minus 3. 6 over negative 9. Negative 2/3. Okay? Okay, let's go to number 12. What comma 2? What comma 0? Okay, delta y is equal to 0 minus 2 over 4 minus 4. Whoa, that's a problem. That gives us negative 2 divided by 0. Okay, that would be negative infinity. Technically, you can't divide that. So this is going to be a special case. This is going to be a vertical line. See, because it's got the same x coordinate. It's going to be the point. Let's just plot this one out. It's going to be the point that goes from 4, 2 to 4, 0. It'll be a line that just goes like this. Okay. Yeah. Now, the delta, on this one, the delta y was as a negative 2. Now, if you had a slope of infinity, positive infinity technically would be a line that was vertical, but it would be slightly pointing to the right. And negative infinity, see, what happens here is a slope of a line like this is negative, and then it gets larger and larger and larger, approaching negative infinity as it gets vertical. The one on the right, that would be a slope of 1, 2, 3. It keeps getting more positive until it approaches positive infinity, which is when it's vertical. So when the slope of a line is vertical, we could call the slope infinite. I'm not quite sure what they say in this chapter about the so-called vertical line case. This is a special case or a trick question. Okay, I see what they have. They say undefined slope. So they don't want to get into the infinity. I could call the slope vertical. I could call it infinity. Calling it undefined, that's what they want to do. I wouldn't really say it was undefined, but that's what the book says. Vertical. It's perfectly well defined. Vertical. Okay. Now, that was number 12. Okay, let's go to number 14. Number 14 says find the slope, and this gives you an actual example. It shows a point going through 3, 4, and it shows the y-intercept at -5. shows a line going between these points. This would be the point 0, comma, -5. It's conventional sometimes to put these in parentheses. Well, you find the slope exactly, this is exactly the same way as we did before. Once you identify the 2 points, delta y or delta x, it's going to be 4 minus the -5, which is 4 plus 5, divided by 3 minus 0. It's the difference in the y coordinates divided by the difference in the x coordinates. And that's equal to 9 over 3, or 3. So this has a slope of 3. Okay. Okay, now let's do number 16. 16, I can see this goes through a point 4, -1. That would be out over here. And also goes through a point 4. I'm sorry, it's a point -1, comma 4, because I've been writing them out as x, y coordinates, so I should say the x coordinate first. But I got a little sloppy there. I said the y coordinate first. So this is the point 4, comma, -2. Okay? So this is the line that goes like this. Okay? But the slope is equal to delta y over delta x. Now, let me just write this out because it helps not make a silly mistake. The x, because I have to write down as the x coordinate first. -1, comma, 4 on this one. And this one is 4, comma, -2. X coordinate is 4. X coordinate is -1. The y coordinate here is 4. It's actually a little bit lower there. Okay? And the y coordinate here is -2. So once I do that, it's a lot easier because now I just go from the second point. I'm just going to call that the first point. I'm going to call that the second point. It won't really matter which way I do it. Okay? -2 minus 4 over delta x. So delta x is 4 minus -1, which is 4 plus 1. Let's go to -6 over 5. Okay, -6/5. That's the slope. Okay, let's go to 18. On takeoff, a Delta Airlines jet climbs to 3 miles as it passes over 25 miles of land. 25 miles. Okay, and then I'm sure they're going to ask, what is the slope? Find the slope of its climb. Yeah, actual slopes that you encounter on Earth, going up a hill or something like this, they tend to always be relatively low. Things don't get that steep. Well, this is just the rise divided by the run. In this case, we wouldn't really call this delta y or delta x because we don't have coordinates, x and y coordinates, but we do have what's known as the height or the rise, and then what I call the run. So this slope just equal to 3 divided by 25. Okay. Now, number 20. Driving down Bald Mountain in Wyoming, Bob Dean, okay, finds that he descends 1,600 feet in elevation. So I'm just going to make a little diagram. 1,600 feet in elevation by the time he is 2.5 miles horizontally away from the high point on the mountain road. Find the slope of his descent. And the hint is that 1 mile is equal to 5,280, and that's just one of those numbers that we learn sometimes in grade school, and then you memorize it and remember it. 5,280. It's also 176 yards. Okay, multiply yard by, no, that doesn't sound right. 1,760 yards is a mile. A tenth of a mile is 176 yards. Because I used to run on a track that was 10 laps to a mile. One time around the track was 176 yards. That's how I did it. That's just happened to be why I remembered that number. If you multiply 1760 by 3, you'll get 5,280. Okay, now, so this scale has been greatly exaggerated. 1,600 feet, that's only about a third of a mile. This is 2.5 miles, so once again, going down a hill, usually it's never that steep. Okay, so we'll just take this on face value and try to calculate the rise over the run. Okay, and we're going to put this as a negative number since we had him going downhill in the direction of that he's moving. Okay, the slope really could be, there's really no big difference when you're talking about land or mountain or what have you. There's no real difference in the slope being a positive or a negative. It really has to do with whether or not you're going up it or down it. And that depends on an XY plot. We talk about the slope, but like I said before, if it moves up to the right, but remember now, that's just by convention of having a positive x-axis. And on the Earth, there's no positive x-axis plotted on the Earth anywhere. So you have to take from context. The context of this question was that he was driving downhill, so the idea is they probably want a negative slope, but that would be the same as the positive slope of the mountain if someone was going up it. I mean, the slope of the mountain is the same. Anyway, we're just going to take delta y divided by delta x. Or the rise over the run, okay? And we'll do it in feet because that makes it a little easier because you're at 1,600 feet on the top. At the bottom, you had 5,280 times 2.5. So this is just a matter of simplifying this fraction, and we're going to call it as a negative. Like I said, I thought that'd be more appropriate. So first we'll take off the zeros, okay? And then we'll always be looking for something else to take off. 2.5 is 5 over 2, 5 halves. So I would change this, for example, to be a 5 on the bottom and a 2 on the top, because that's 1 over 5 halves. It was 2.5. And that makes it a little easier to cancel some of these things out. A little bit. 15, yeah, this is divisible by, they're all divisible by various numbers. If you had a calculator, it makes it easier, but let's just go, and for example, take the 528 and divide it by 2, right? 528 divided by 250, it's half of 500, 264. Okay, so if we get rid of this 2, this becomes 264. Assuming I didn't make a mistake. And if we get rid of this 5, 5 goes into this 32 times. 10 would go in 16 times. We can get rid of this and turn this into a 32. Now you can draw factors of 2. For example, this, if you divide, this is divisible by 2, this is divisible by 2. This would be equal to 16. If you take half of it, you take half of this, you get 132. Take half of this and you'll get 8. Take half of this and you get 66. 66. Take half of this, you get 4. And half of this is 33. Now you have it down to the point where there are no more common factors. That's 3 times 11. That's 2 times 2. So that number you just have to put into your calculator. It's a little bit more than 1/10. So I won't calculate. You can put it into a calculator, but I thought it might come out to a nice round number, but it didn't. So okay, now let's try this one. Find the slope and the y-intercept of each line. So y is equal to x plus 2. Okay, now the thing about this one is, what you want to do is you want to learn that a general equation for a line can be written as y is equal to mx plus b. Okay, I learned this in grade school or junior high or high school or junior high school, I guess. And when an equation is placed in this form, this ends up to be the slope, and this ends up to be the y-intercept. Now, it's not hard to see why this is the y-intercept, because when x is equal to 0, that's the value, this term in the middle is 0, and y is equal to b. So when x is equal to 0, y is going to be b. That's why this turns out to be the y-intercept, right? And it's not hard also to see why this ends up to being the slope, because remember now, the slope is defined as the rise over the run, or delta y divided by delta x. So the idea of this is that if you had a particular point, x1, y1, which satisfied this equation, and then you increased x by 1 more, okay, so delta x will equal to 1. If you increase this by 1 more, the y, which is on the left-hand side of the equation, would increase by m times that 1. That would be m. So this is for every increase of x, y increases m times that. And that's really what the slope is all about. It's how much does the y increase for every increase in x, how many times. So but after a point, you just memorize this. You just know it. Y equals mx plus b. It's like learning the alphabet. Okay, and then you just look at this, and it's pretty obvious that the slope m is 1 and b is 2. So the answer to this one is m equals 1, b equals 2. Okay? And for this particular section, I'll just write y is equal to mx plus b on the top. That's the form we want to put these into. So the next one, 24, so y is equal to negative 2x plus 6. M is equal to negative 2, b is equal to 6. Okay? You just have to correspond them. Okay, here's one. This one is written, it's not in the standard form already. Negative 5x plus y is equal to 10. But what we'll do is we'll just move the 5y to the other side. Get y is equal to 5x plus 10. M equals 5, b equals 10. Okay? Y-intercept is 10, slope equals 5. Okay, let's go to 28. Negative 3x minus 4y is equal to 6. Okay, now we want to get the y out by itself. So I'm going to say let's move the 4y to this side, move the 6 to that side, put it as the y on this side. So this is equal to negative 3x minus 6. Okay, just move them around to get it, because I'm trying to get it to be like this form. Now I'm going to have to divide by the 4. Put the 4 on the bottom, and take it off there, see? On the whiteboard, it's easy. It's not so easy on paper. Usually on paper, you have to write more lines. On the whiteboard, I can just erase a few things. Like I can just take that and say, oh, that's just 3 over 2. But of course, sometimes when you erase things, you make a mistake. Then you can't find where your mistake is. So I usually like to write out lots of different lines, okay? But you don't want to write out a line for every little possible step, okay? Now, here I moved these around, and I got it to look like this. So the m is equal to negative 3/4. B is equal to negative 3/2. Okay? Now, let's go to 30. Oh, I erased my prototype. Okay, 30. X equals 7.2. Well, x equals 7.2, that's going to be a vertical line. That's going to be a line like this. So what we know is that the slope, or m, I would say, oh, it's going to be infinite, but actually you might say no, it's undetermined. Because we're not going to be dealing with infinite numbers. And also, it's a vertical line, so there is no y. It doesn't intercept the y-axis, it's parallel to it. So b, or the y-intercept, oh, that's undefined. There is none. Or so there aren't. You don't have numerical answers to this. Okay, you just write down it's vertical line. Slope is vertical or undefined. Okay, let's try this one. Okay, y is equal to negative 3.6. Okay, now this, on the other hand, does take on the same form as that, only that it's going to be that m is equal to 0 because there is no term there, and the b is equal to negative 3.6. Okay, and that's the so-called horizontal line. Now, some people would argue that a horizontal line, there's really nothing special about a horizontal line as compared to a vertical line. And the slope of the horizontal line is called 0, and the slope of the vertical line is called undetermined. Okay, but it would turn out to be an infinite number. So there is something unusual about that vertical line. Okay, now 34. Y is equal to negative 1/4 x. So the m, or the slope, is equal to negative 1/4. And b, the y-intercept, is equal to 0 because that term would be 0. Okay. Now let's go to this one. 2y minus 7 equal to 0. No, equal to x, I'm sorry. Misread that. Okay, so we want to get this to look like y equals mx plus b, so we take the 7, put it to the other side, divide by 2. Y is equal to 1/2 x plus 7 divided by 2. m equals 1/2, b equals 7/2. Okay. Okay. 4x minus 7y equals 28. Move this 7y to this side. Move the 28 to the other side. Flip everything around. Divide by 7. But let me do that in 2 steps. 7y equals 4x minus 28. Especially when you're working on a test, you don't want to do too much in your head because you can easily make a mistake. When you work carefully, you want to write out more lines. Okay. Now, 7 times 4 is 28, so this is actually 4. So m, well, that's the slope is 4/7. The y-intercept is negative 4. Okay, now that brings us to number 40. Y is equal to 1/7 times x. And this is already in the form of the prototype. So the slope is 1/7. The intercept is 0. Okay, the next one says y minus 7 equals 0. So we can put this into the form of the prototype by saying that y is equal to 7. It's a horizontal line. M equals 0. B equals 7. Okay. Now, this is a very long section. This one gets on to now match each equation with its graph. And they give us four possible lines. And I'll just draw in what these four possible lines were. One of them intersects at 3, 1. And it's a line that looks like this. Okay. Another one is intersects at 3, 1. And it looks like it's going the other way. I'll call this line A. I'll call this line B. Then they have a line C, which starts off down here at 3. Looks like quite similar slope, actually. We'll just draw that as a parallel one. It looks quite parallel. That's called C. And then there's a D, which starts down here, and it looks like it's like this. Okay. And now they have the equation y is equal to 2x minus 3. Which of these does it match up to? Well, this has a slope of plus 2. And the intercept is equal to -3. So you look at these lines, -3, that gets you down here, and the slope that's positive is d. So this one is d. Okay? And then number 46, it says y is equal to -2x minus 3. Okay, this has a y-intercept of -3, but the slope is -2. So it's going to intercept down here, and it's going to go like here. So this one is going to be C. Okay. Okay. Now let's see if I can get these off. Not too much trouble. One, two, three. Now they're making my line a little bit messy. Okay. Now, let's get on to 48. It says two lines are graphed on each set of axes. For each graph, determine whether L1 or L2 has the greatest slope. And I'll just do this up here as a little side plot. Okay, this is not a quantitative question. This is a qualitative question. Okay, so L1 is looking like this. L2 is looking like this. And they put arrows on each end of these lines. Which one has the greater slope? Oh, that's an interesting question. They don't say whether they mean greater in magnitude or taking into account the sign. See, if you have one that's negative, well, they say it's greater, but anyway, I think the point on this one is that these look to have about the same slope in magnitude, but L1 is a negative slope and L2 is a positive slope. So if you want to say which one is greater, you might say L2 is because it's positive, and that positive you might say is greater than a negative. Okay, but
Not so sure exactly about that.
Now, y and x, here's another one.
Here are the two lines.
L1 is like this, and L2 is like this.
Okay.
And which slope is greater? Well, this slope is 0. And this slope is positive, so L2 is greater. And the slope of line L2 is greater.
And that brings us to 42.
And this one, what they're showing here are two positive slope lines. One of them is L1, the other one is L2. And in this case, L1 has a greater slope because it's more to the vertical. Okay, so L1 is more to the vertical, so L1 is a greater slope there.
Okay, now let's get to 54. Determine whether each pair of lines is parallel, perpendicular, or neither.
So let's say we get y is equal to 5x minus 6, and y is equal to 5x plus 2.
The idea on here is it's all about the slope. Parallel lines are going to have the same slope. Perpendicular lines are going to have slopes that are reciprocal, like delta y over delta x.
If you have a line like this, and it's got a certain delta y and a certain delta x, if you had a line that was exactly perpendicular or at 90 degrees, it would have, yeah, well, I drew this at 45 degrees, so it makes it hard to see, but the role of delta y and delta x are reversed, so let me make one at a slow angle. You'll see it now. If this is delta y and this is delta x, and you had something that was perpendicular to this, okay, what you'd find is that the rise over the run, this height is going to correspond to that, and this height is going to correspond to this width. Okay, so if you call this delta y1, delta x1, and you call this delta y2, and this is delta x2, if these are at 90 degrees, the idea about 90 degrees is the role of x and y have been reversed because it's the x-axis is like it's the y-axis. So what was the rise on this is going to be exactly the same as what the run is on this if this line is at 90 degrees. So the idea on this is that the slope of this, that is the ratio of the y to x, is going to be the inverse, that is the multiplicative inverse, or what I call the reciprocal of the slope on this one. So the idea on that is if you multiply the two slopes together, you'll actually get a -1. See, one of them slopes, for them to be at 90 degrees, one slope has to be positive and the other has to be negative. Okay. So the trick on that is you multiply the two slopes together and you get -1. They explain that in the book. Okay. You could have, let's say you take something with a slope of 2, for example. Okay, so that means that the rise over the run is 2 over 1. Now you can have something with a slope of 1/2. That means the rise, that means if it was like this, the rise is 1 and the run is 2. This let's say has a slope of 1/2. This has a slope of 2. These slopes are reciprocal in the sense that this is 2 over 1 and that's 1 over 2. But these are not perpendicular because they're both positive. When they are reciprocal and one of them is the negative of the other, that's when you get to the 90-degree case, the right angle case. Okay, now let's just look at this one. The slope is 5 on both of these, so these are parallel. Okay. Remember, you spelled parallel with 2 L's because those are the parallel lines. Okay. Now let's go to 56. And this is y is equal to 2x minus 12. Y is equal to 1/2 x minus 6. Well, the slope on this is 2, and the slope on this is 1/2. But they're both positive, so they're not perpendicular. They're just, one is at a certain angle, the other is at half. One's at a certain slope, the other's half of that slope. So this one is going to be neither. They're neither parallel nor perpendicular. Okay, let's go to 58. Negative 2x plus 3y equals 1, and 3x plus 2y is equal to 12. Well, we want to put these into the standard form. So we put the first one in the standard form, and it's going to be 3y is equal to 2x plus 1. Then we're going to divide through by the 3. Okay? The second one we're going to put in standard form. It's going to be 2y is equal to negative 3x plus 12. Then we're going to divide through by the 2. Get rid of the 2, and then we'll change this to a 6. See how I'm using more of the whiteboard now? To write multiple lines, I'm doing more in one step. Okay. Now this one, you can see that these are going to be perpendicular because this is the reciprocal of that. The rise to the run, the ratio of the rise to the run, or the delta y over delta x is going to be in the ratio of 2 to 3 for this line. On this one, it's going to be in the ratio of 3 to 2 in the negative direction. So that's going to give you a line that's pointed off in exactly the perpendicular direction. Okay, that's 58. And now the last one of the day is number 60. Okay. Y is equal to 5x plus 8. And y is equal to 1/5 x minus 8. And this is another one where it's going to be neither, because the slopes are reciprocal, but they're both positive, and they're both pointing in the same direction, so it's not going to be perpendicular. So that's neither. Okay? And that is all of the ones for today. That was a long session. So, thank you.